We're going to spend a lot of time talking about polynomial arithmetic. We just went over a polynomial, many terms. Arithmetic is what you've been doing with numbers since like kindergarten. 5 plus 5 is 10. That's arithmetic. Now we're going to be doing this arithmetic with polynomials. We're going to spend today working on, highlight with me, adding, subtracting, and multiplying these polynomials. Dividing is kind of tough, so dividing gets like 2, 3, and 4 days to be doing it. But we're going to be adding, subtracting, and multiplying polynomials today. Adding and subtracting is going to be easy. It's going to be looking like something you've done before. Multiplying, I'm going to have to teach you how to do. The rules for adding polynomials are as follows. 1, line up the terms. And then CLT. What does CLT mean? CLT means to combine like terms. So we're going to be adding together the things that are alike. Line up the terms and CLT, because all we're doing is adding a binomial with a binomial. Okay? We line up the things that are like. So underneath this 4x, from the second parentheses, what am I going to write down underneath it? 2x. Okay. What do I write underneath the positive 3? Negative 5. Now I'm going to add these so I can combine like terms. I'm going to add in a column, kind of like we used to do adding in elementary school. 4 plus 2 is 6x, and 3 plus negative 5 is negative 2. So when I add 4x plus 3 and 2x minus 5, I get 6x minus 2. I'm done. We've added the polynomials. That easy. Prove it to yourself it's that easy. You've got example 2. Try that one out. So since I'm lining up my like terms, I'm going to take the 6x from the second parentheses and line it up underneath the 7x from the first one, and line up the negative 4 underneath the 2. Combining like terms is adding. 7x plus 6x is 13x. 2 plus negative 4 is negative 2. 13x minus 2 is the sum of those two.
I'm good now.
The rules for subtracting are close to the rules for adding. They're just a little bit different. The steps for subtracting are to line up the terms. But instead of using exactly what you see, since we're subtracting, we're going to use the opposites. Because we're multiplying by a negative 1, essentially, we're distributing negative 1, we'd end up with the opposite term underneath. Then we CLT. What did CLT stand for? Combining like terms. Thank you. We're changing the term of the second piece. Okay, because we're subtracting the second one. Whichever one we're subtracting, that's what we're going to change the sign of. So I'm going to be changing the sign of 9x and negative 2 when I write them down. So underneath the 6x, what am I actually going to be writing? Negative 9x, because it's the opposite, because we're subtracting it. What am I going to write down underneath the 7? Positive 2, because it's the opposite of what's there. Then it looks like an addition problem. If you've written down the opposites, it's exactly an addition problem. 6 plus negative 9x is negative 3x. 7 plus 2 is a 9. Subtracting is adding the opposites, because subtracting and adding negatives are exactly the same thing. So I line up the opposite terms, and then I combine like terms. Just add in the columns. Questions, comments, concerns before I make you try one? All right, you've got number 2. Flag me down if you actually do have a question. The opposites are what go underneath. So instead of negative x, I'm going to be writing down positive x. Or positive 1x if you need to see the ones. Instead of positive 4, I'm going to be writing down negative 4. Then I combine my like terms. 2 plus 1 is 3x.
Minus 7.
Negative 3 plus negative 4 is a negative 7. So 3x minus 7 is the sum of those two binomials. The difference of those two binomials.
That's binomial?
Two terms?
The multiplication was hard.
Why are there Punnett squares?
We'll get there.
Do we have to use them?
I will get there.
Yeah, we'll get there.
Because we do it in my...
First 4 on the inside of your packet are practice problems for adding and subtracting. It doesn't tell you exactly what to do. You have to make that decision. Okay? If you look at number 1, what's different from number 1 and the ones we did on the front?
It's a trinomial.
It's a trinomial. It has a bigger exponent. Does that change what you do?
No.
No, you still line up your like terms and combine them. So on number 1, you've got 3x squared minus 4x plus 2 plus x squared minus 8x plus 1. We're going to line up the things that are like. What do I write down underneath 3x squared?
X squared.
And for those of you who need a number in the front as a coefficient, what do I put there?
1.
Okay. What do I write underneath negative 4x?
Negative 8.
And then underneath 2 is a...
1.
These are going to be adding. We should end up with 4x squared minus 12x plus 3. Now I'm going to take a second here, and there are going to be problems, not this one, where when you get the sum or the difference, it's going to look like this. Now, while this is still a correct answer, what's different about the one I boxed and that particular one?
You
It's just
went
switched.
least. You did most
You
to
switched
least.
it.
I switched the order, and it should be in which order?
Greatest to least.
Great. What greatest?
Oh,
What's greatest though? You're right.
the exponent.
The exponent. Do y'all see how here this has an exponent of 2, an exponent of 1, and then like no exponent, an exponent of 0? Okay. This is a better and more correct answer. This is what answer choices will look like. If you answer for me today, the out of order version, I guess it's okay, but I need it in the correct order, which means you need to rewrite them to where the biggest exponent goes first, and then it slowly gets smaller. Does that make sense? The biggest exponent goes first, then it gets smaller each time. Okay? Let's look at number 2. What do you notice about number 2?
There's a bi and a trinomial.
There's a binomial and a trinomial. We're still going to add them up, but since they're different dimensions, is there going to be something on top and bottom for every single part?
No.
No, because something's got some extra. So let's line some things up. What do I line up underneath the 12x?
5x.
What do I line up underneath the 5?
Negative 1.
And what have I not lined up under anything?
X squared.
So would it be better for me to write the positive x squared back here or in the front?
In the front.
I agree. Why would it be better for it to be in the front?
Because it looks like you're adding x squared plus x squared.
Yeah, that's going to be the order I want, right? I want the biggest exponent in the front. So I put it over there. All right, now let's add. Nothing gets combined with x squared. 12 plus 5x is 17x. 5 minus 1 is a positive 4. And that's the sum of those two polynomials, the binomial and the trinomial. Did I lose anyone on the fact that they are different dimensions?
No, ma'am.
No. Nope. No.
All right. On number 3, what is it asking for you to do?
Subtract.
Subtract. So are you just going to line up the exact same things?
No, you're gonna change
We're
them
gonna
to the opposite.
Change them to their opposite and then CLT. Cool. You know how to do it. Number 3 is yours. If we're lining up the opposites, underneath the 3x squared should be what?
Negative.
Negative x squared or negative 1x squared. Because it's the opposite. What should be underneath the negative 4x?
Positive 8x.
The opposite, positive 8x. And then I have a minus 1. Now I'm adding these together. Combining like terms is adding whatever sign they are. So 3 plus a negative 1
2x.
is 2x squared. And negative 4 plus 8x,
4x.
2 plus negative 1.
1.
So the difference here is 2x squared plus 4x plus 1. If you look at number 4, it looks kind of crazy. What's happening here?
You have subtraction.
You gotta try something.
Yeah, we do have to try something. We have an addition problem and a subtraction problem. Don't mark this out, but let's say I did this. Does that look manageable?
Yes.
Yeah, what am I doing in the first part of this question?
Adding
Adding. Where am I going to line this up?
to the negative 6x squared.
What, this one? The 4x? Where am I going to put the 4x?
You didn't
Yeah,
find.
put it nowhere.
Put it, just to put it by itself?
Yeah.
Okay, what about the negative 6x squared?
You put it under the 2x squared.
Okay. I'm going to add these together, and I would get negative 4x squared plus 4x, right?
Yeah.
Okay. Now, if I uncover the part I covered up, don't I still have this part right here?
Yeah.
Now, what kind of question do I have?
A subtraction.
A subtraction. Am I going to line up the sames or the opposites? The opposites because I'm subtracting. What's the opposite of x?
Negative x.
Negative x. And negative x is going to go underneath the 4x. What's the opposite of 3?
Negative 3.
And it just gets to chill by itself because there's nothing like it. We'd end up with negative 4x squared plus 3x minus 3.
Oh.
This is a very complicated question. I will not ask you something this hard on your homework. So if you understand the first 3, we're in business. This is just taking it and adding more parts in case there were multiple parts to a question. Does that make sense? If you haven't written this one down, please go ahead and write it down just so you have it. It's a good one to have in our arsenal, but it is not something, I moved it up, sorry. It's not something I desperately need you to do today. Eventually, yes. All right, if you're not done writing it down, I got you at the end of class. We're going to go back to the front page. We left off here at multiplying polynomials. I'm going to show you 2 methods to solve polynomials. Okay, my goal is to use this organized method of the Punnett square method to get you to be able to do FOIL, or what's called double distribution. So our goal is to go this direction and use FOIL or double distribution, but if that's not for you today, we can use the Punnett squares. In fact, for the next week or 2, maybe Punnett squares are for you, but I will tell you right now, we need to be able to FOIL these questions or use double distribution because it's faster. It will make problems a lot easier to do. You'll save paper, and your Algebra 2 teachers will want you to do this way instead of this way. They will let you probably do this, but they're going to want you to use FOIL. Does that make sense? So I got you. We'll use this until we get good at it, and then we'll start transitioning to FOIL. If you like FOIL today, cool, great, awesome. You don't have to use a Punnett square. Speaking of Punnett squares, how many of you guys are in biology? So you guys know how to use a Punnett square, right? It's when you're crossing genetic traits between plants or humans or whatever. If don't write this down, just watch. If I were crossing some sort of plant that had some genes or alleles that could be expressed as big K, big Q, little q. What, my biology friends, would I write in this top box? Don't write this down. Capital K, capital Q. Oops. Capital K, capital Q. Don't write it down. You're just watching. What would I write in the next top box?
Capital K, lowercase. Capital Q, lowercase k.
What would go in the bottom box?
Capital K, lowercase k.
And in the last one?
Lowercase q, lowercase k.
Okay, what's happening here in biology is that you guys were taking the alleles for each column and row and putting them next to each other. Just like you would make a multiplication chart. If this said 2 and this said 3, 2 times 3 would be 6. 6 would go in that box. That's what you did with alleles. Well, we're going to do that with parts of our polynomials because we can do a multiplication in this organized method that ends up looking like a Punnett square. In math, when 2 things are smushed next to each other, what are we doing with them? Multiplying. So up here, I have the polynomial 3x plus 5 times 2x plus 3. If you haven't highlighted that yet, go ahead and highlight it because it's kind of tucked in there, so you might not see it. We're going to be multiplying these because they're smushed right next to each other. That means multiply. We're also going to smush things right next to each other in these boxes, which means what are we doing with each little piece? Multiplying. Here's how we use the Punnett square to do some math. Along the top, you take the first polynomial, which is our binomial 3x plus 5. And you're going to write it up at the top. Here's 3x, and here's my positive 5. along the side where the other alleles went is going to be the other polynomial. 2x and a positive 3. Now, if this said negative 3, I'd put a negative sign right here. Does that make sense? Yeah. Okay, whatever number is there is what I'm going to use. We start crossing these polynomials, but you're not going to write down 2x next to 3x. You're actually going to do that multiplication. So what is 2 times 3?
3.
And then what is x times x?
X.
Ugh.
X to the power of 2. X squared.
Thank you. We asked you this at the door. What's x times x?
X to the power of 2.
X squared or x to the power of 2? Y'all, that's got to be something we like. Say in our sleep. Okay.
I don't talk in my sleep.
Or do you? Then we're going to do the next one. This column is 5. This row is 2. So 5 times 2x is 10x. Then we do the next column and row. 3x times 3, 9x. 3 times 5, 15. Does everyone see how we filled in the Punnett square? What do you notice about the numbers that are on this diagonal?
They're both X's.
They're like terms. They're both x's. So what do we do with like terms?
Combine like terms.
We combine our like terms. We're going to add them. Look at this plus sign that sits right in the middle of them. 19x. Now, to finish answering our polynomial, the cross, the multiplication, the product of them is taking the corner pieces that I didn't highlight and the combined like term and writing them in a single expression. This would be 6x squared plus 19x plus 15. I took the corner pieces, 6x squared, 19x, and 15, and wrote them as a trinomial. And that's the product of these two binomials. It should get bigger. We're multiplying, so you should end up with more terms. Okay? You take the corner pieces and anything you've combined together, which is our diagonal. That's the Punnett square method. You're totally allowed to use the Punnett square method if you like it. But my goal is to get us to use double distribution. Double distribution is called FOIL. This is our second technique because FOIL exactly spells out the order that we're going to multiply. Okay. What numbers are the first in both of the parentheses?
3x.
Let's multiply those. What is 3x times 2x?
6x squared.
To the power of 2.
Thank you. O in FOIL stands for the outside. Do you agree that 3x and 3 are on the outside of this problem?
Yes.
Okay, let's multiply them. 3x times 3.
9.
Then I, what do you think I stands for?
Inner.
Do you see how these two are on the inside of the problem?
Yeah.
We're multiplying them. 5 times 2x is,
10x.
and then the L, what do you think that stands for?
Less.
Do you agree that both of these are last in their parentheses?
Yeah.
We're going to multiply them.
15.
Okay? Just like with the Punnett square method, we're going to end up with some like terms. Where are your like terms here?
9x and 10x.
Yeah, right there in the center, correct? If you combine them together, what do you get?
19x.
So you'd say this would be 6x squared plus 19x plus 15. Yeah, guess what? That's the same answer you got using the Punnett square method. In fact, it's the exact same numbers you got in the box. Do you see that? This Punnett square method is an organized visual version of using FOIL or double distribution. You've got 6x squared, it's in both. You've got 9x, it's in both. 10x is in both. 15 is in both. We combine our like terms in both to make 19. Either way works for now. I would like for you to really get into foiling. That's okay. Other word for foiling, if you go anywhere else and they don't call it foiling, it's called double distribution. Can I show you why? Okay. If I only had this part right here, didn't I distribute the 3x to both pieces inside? 3x times 2x, and then 3x times 3. and then pretend like this part doesn't exist. Isn't this 5 times 2x and then 5 times 3? We've distributed twice, aka double distribution. I know. Mind blown. But if you have a binomial times a binomial, it spells out FOIL. F-O-I-L for first, outer, inner, last. We're going to go inside and we're going to practice this some more. I'm going to do one more with you and then you're going to try on your own. You're allowed to have an opinion today on which way you like to do. So if after we do the next couple using both methods, you're like, honestly, FOIL's for me, go for it. Or if it's like, honestly, Punnett square method is for me, go for it. We're going to look at number 5. The instructions here say to write a simplified equivalent expression for the following problems. Use both the Punnett square and the FOIL method. So we're going to do each problem twice just to get used to both methods. On number 5, I need to set up the Punnett square. What size Punnett square am I going to need here?
Square. 2 by 2.
A 2 by 2. How did you know 2 by 2? There's 2 pieces in each. This is a binomial times a binomial, so it's going to be a 2 by 2. So let's draw our squares. Pardon my drawing because they're never straight. Hey, it's pretty good. That's actually pretty good for me.
On the left corner, why is it not connected?
Oh my gosh, details. There, is that better?
Okay.
On the top, guys, what's going to go across the top here? X and a positive 9. What goes on the side? X and a positive 1. If I like it to see the plus sign, if I'm like, where'd that plus sign go? You can put it there if that helps you.
Do we have to do the Punnett?
X squared.
You have to try both right now.
I just finished.
You have to try both just now. Later on and on your homework, I'm going to let you have an opinion and choose whichever one you like. But for now, you're doing both. Now we start crossing these. What goes in the first box?
X to the power 2.
What goes in the second box?
9x.
9x.
What goes in the bottom box?
1x.
X.
Or 1x, yes. And then the last one?
9x.
9. Oop. 9 times 1? Okay. Now, where are my like terms? On the
9x.
on the diagonal. So highlight or circle them. And what am I going to do with my like terms?
You're gonna add them.
I'm going to add them, and it would be 10x. Now, so how do I write the final trinomial answer here?
X squared, 10x plus 9.
10x squared.
Where are you getting all these numbers?
Remember, when you combine like terms, you do not change the exponent. Exponent rules only occur when we're multiplying, dividing, or raising a power to a power. Adding and subtracting, you just combine the coefficients. Don't change the exponents. Okay, this is what we think the answer is going to be from the Punnett square method. This is the trinomial product, or answer. Let's try it using FOIL. Double distribution. What does the F stand for? First. So we're going to multiply the first. What's x times x?
X to the power 2.
X squared or x to the power of 2. Then we're going to multiply the outers. What's x times 1?
1x.
I'll write the 1 this time. What's the I stand for? Inner.
Which is 9x.
Thank you. And then the L stands for? 9 times 1 is? Where are the like terms in the FOIL method?
They're at the, and they're in the middle.
They're usually in the middle. Words are hard. No, we're adding. Combining like terms is adding. So this is going to be x squared plus 10x plus 9. Isn't that the same answer we got? You are allowed to have an opinion soon. For the first few, I do need you to do it both ways. Because sometimes you form your opinion too early and then you like actually want to change your mind. So I want you to do number 6 with both the Punnett square first and then FOIL. Yes, you have to do both. I want you to do both. What size Punnett square am I going to have to set up for number 6?
2 by 2.
2 by 2. Because this is a binomial times a binomial. 2x and negative 3. 6x and a negative 5. We're going to multiply into these boxes. 6 times 2 is 12. X times x is x squared. Negative 3 times 6 is negative 18x. Negative 5 times 2 is negative 10x. Negative 3 times negative 5 is a positive 15. On my diagonal are my like terms. What do I do with those numbers? I add them. I would get negative 28x. So once I put it all together in the correct order, should be
12x squared
minus 28x
plus 15.
plus 15. That is correct. So those of you still working on the FOIL method, you know this is the correct answer you should get. Make sure you can FOIL it as well as Punnett square it. My FOIL friends, I'm sorry if I'm cutting you off, but when we do FOIL, we're going to either just think about double distribution or the letters FOIL. F stands for first. 2x times 6x is 12x squared. FO, outsides, is negative 10x.
Yes.
Insides, negative 18x. Last, positive 15. Where does the what?
No, wait, never mind.
One thing I saw a lot is that we weren't bringing our signs with us. Remember, you actually have to multiply by what sign is there. Don't give me positive numbers forever. If there's negative numbers, actually multiply by them.
Those are two different answers.
You're correct, we're not finished. Aren't our like terms here in the center?
Yeah.
If we combine our like terms, we would get 12x squared minus 18x plus 15. Are those the same ones?
No.
Oh, because I can't add. This is 28.
What? You got me confused there for a little.
Sorry, my human is showing. Those are the same.
I got it.
Nice. We're going to do this next one together because I'm about to make it crazy. If you look at number 7, what do you notice about number 7? Wait, it's a what times a what?
Binomial.
It's a binomial times a...
Binomial.
So what kind of boxes are we going to have to set up for a binomial times a trinomial? Is it going to be a square?
No, it'll be a rectangle.
It's going to be a rectangle. So there's going to be 2 across the top, and how many along the side?
3.
Okay, here's what your box should look like. 2 by 3. It's got to be the same size as the stuff that you have. Trinomial times binomial times trinomial.
So is it like
Okay.
So Abby says that x and 5 go on the top. That's true. What goes along the side?
X to the power of 2 or x squared?
X squared, 5x,
and
negative 1.
And negative 1.
Okay. Stay with me. Don't get ahead of me. Stay with me. Don't get ahead of me. Stay with me. Don't get ahead of me. In this first box, I'm going to be multiplying what times what? What is x squared times x?
1x squared.
X squared.
X to the power of 3?
X to the power of 3 because we add the exponents together.
Yeah.
This is x cubed because this was 2 and this one is 1, so I add them up. Okay, the next box, what am I multiplying to get the next box?
5x squared.
5 times x squared, which is 5x squared. This row is going to be x times 5x. What is x times 5x?
5x squared?
5x squared. Because x times x is x squared. What about the next box? What goes there?
10x. No, 25x.
25x. Remember, we're multiplying here. This is a multiplication problem. X times negative 1 is
1x
negative 1x.
and negative 5.
And 5 times negative 1
Negative 5.
is a negative 5. Now, there's a lot going on here, but what do you notice about the diagonals?
They're all the same.
The same. Every single one.
We can still add our diagonals together.
10x squared.
It will still have your like terms on a diagonal when you use the Punnett square method correctly. So 5x squared plus 5x squared is 10x squared. 25x plus negative 1x is 24x's. So my final answer all put together would be x cubed plus 10x squared plus 24x minus 5. Woo, look at that polynomial.
Yeah, it's more than 3.
More than 3, we don't call it a we call it a quadnomial. Okay. Now, some of you, for polynomials that are bigger, like binomials times trinomials, Punnett square method is where you'll probably stay. If you want to do FOIL for this kind of problem, it actually doesn't follow the letters FOIL anymore. It follows the idea of double distribution because FOIL is double distribution. Okay, so what we're going to do is we're actually, don't write this down, just watch. We're going to pretend like this part doesn't exist, and we're going to multiply 1, 2, 3 times. Then we're going to go back, and we're going to pretend like this part doesn't exist, and we're going to multiply 1, 2, 3 times. We've distributed twice, aka it's double distribution. That's our goal. I will go piece by piece, so don't write this down. Write down with me this time. I'm going to go piece by piece, but our goal is to distribute every single piece. This is what FOIL does. It just does it in the cute letters. This doesn't work in the letters FOIL. But if we work this way, we're going to have x times x squared. What is x times x squared?
X cubed.
X to the power of 3.
X to the power of 3. We have x times 5x.
5x squared.
We have x times negative 1, which is
Negative x.
negative 1x. Yep, or negative x. That's the first distribution. But I have to do this all again, distributing which number this time?
The 5.
The 5. 5 times x squared.
5x.
It's 5x squared. Now, here's something that you can do to make your life easier. Where's the other 5x squared? It's written in blue, isn't it? Can't I write them above each other? Because I'm going to combine them anyways.
Yeah.
This idea that we did at the beginning of class, let's just use that. The next one we have is 5 times 5x. What is 5 times 5x?
25.
25x. And then I have 5 times negative 1, which is?
24.
Wait.
Yeah.
Yeah, you're working ahead. I know what you did. Now that we have this, we're going to combine like terms. Where are all my like terms?
Right next to each other. Well,
They're lined up, right? Just like we did at the beginning of the class when we were adding these things together. This would be x cubed plus 10x squared plus 24x's minus 5. And we get to the same answer. So for me, when you do polynomial arithmetic with things that are bigger than binomials, so when you're multiplying binomial times trinomial, if you lose it on FOIL because it doesn't follow FOIL, go ahead and do the Punnett square. But for binomials, those are the ones I really need us to be able to use the FOIL method for, because it's going to be helpful in this class later on if you can do them quickly in the FOIL method as opposed to the Punnett squares. But when you need the Punnett squares, use them, especially for these big giant ones, right? Because this FOIL got weird, right? But the Punnett square was the same. Use whichever one you need to be successful. Work towards FOIL or double distribution. Now, there's going to be monsters. We're not actually going to do number 8, but I want you to look at the monster number 8. What size Punnett square am I going to have to make for this?
3 by 3.
3 by 3. This is what this Punnett square would look like.
It looks like tic-tac-toe.
It does kind of look like tic-tac-toe. All of your like terms would still be on your diagonals. We're not doing this one. But these diagonals would be where you combine your like terms. I'm not going to ask you a question this crazy. Test writers for the STAR have not asked a question this crazy. Usually they ask binomial times binomial, but one time they asked binomial times trinomial. So as long as we can do the Punnett square like number 7, we're set. Cool?
Miss, I got questions.
What's up? The last problem on the notes is pretty cool. We're going to use the FOIL method only for this one to practice that. But it says write an expression that represents the area of the shape below. Highlight the word area. Last year in 8th grade math, you probably learned about some geometry stuff. How do you find area of a shape?
Length by width.
That's volume.
Length by width.
Length times width or length times height or base times height, 2 dimensions, are going to give you your area. Oh, I did write it in highlighter. Okay, area equals length times width. Well, if you look at this picture, what information did they give you? They gave me a length and they gave me a width. So we can just replace the L and the W with those lengths and widths. The area here would be equal to 5x plus 4 times 4x minus 4. Since those two things are smushed right next to each other, what are we going to be doing?
Multiply.
And the way we know how to multiply is either with the Punnett square or with FOIL, but I'm asking you to use FOIL. We're first going to multiply the first numbers in each parentheses. So I'm going to multiply 5x times 4x. What do I get? 20x squared. I heard it. Because x times x is x squared. Then I multiply FO, the outsides. What's 5x times negative 4? Negative 20x. Then I multiply the insides.
16.
16x. Remember, we're multiplying, not adding. And then multiply the lasts. 4 times negative 4 is negative 16. Where are my like terms in this simple FOIL problem?
In the middle.
In the middle. So I'm going to add those together, and I'm going to say that my area is 20x squared minus 4x minus 16. That's the area represented by this rectangle. Okay? Again, you get to make a choice now on your homework. Do you like FOIL? Do you like the Punnett square? You get to choose. I would love for you to do the FOIL. But if Punnett square is where you're at, rock it. Every question uses, you can use both for either. For every question. So you get to have an opinion on how you do your math today. Okay? Now, we're going to spend the rest of the class period working on our homework because you need to do problems, lots of them, so that you make mistakes and then you fix them. You have 2 teachers in here right now who can help you out. Before you leave, I really would like for you to do at least number 1 and 2 on the front and number 11 and 12 on the back to make sure you have at least one example of each type of question before you leave here. Is that cool? If you can do all of your homework, we're going to be good and you can go.